As I look at the C3PO activity, and then I look at the ISS program, which is the operational program that's going to receive this capability, how did that handoff occur? And I would say that it was, again, a lot of team effort back and forth. The station team really focused on what they were concerned about, and they were really concerned that we had an absolute requirement to protect space station. So these cargo vehicles, as they approached space station, that we had to assure that they could not damage space station, and that was an absolute requirement. It was in the contract. It was there, so we could shade it such that if a failure occurred, it would occur such we would sacrifice mission success. In other words, we would not dock, we would not transfer the cargo, but we would not damage space station. So we could build the procedures, build the techniques such that it was biased towards protecting the space station, even though we might sacrifice mission success. So that was a degree of freedom that the station program had that some programs don't. Some programs have to have mission success to actually come up and dock, as well as not damage the or the vehicle they're docking with. But in this case, we had the ability to bias it one way if we could tolerate the loss of mission success. We also developed a fairly ingenious way of, as the cargo vehicles approached station, they would go through a series of checkouts where they would fly into a certain point. We would check out all the systems, make sure they were functional. Everything worked the way it was supposed to. All the rendezvous prox op stuff worked. The vehicle was located where it was supposed to be located. And then we would give them permission to fly the next step a little bit closer to station. We'd check out all the rendezvous prox op stuff, all the approach software, understand how the vehicle's actually operating. Was it flying the way it was supposed to? Then they could come in a little bit closer and then finally come in all the way to dock. So we did this demonstration flights where we did this approach, where we were able to essentially buy down the risk incrementally as we moved into station to make sure that station was not at risk. We were also able to add a little bit of cargo to those demonstration flights. So the station program added some cargo to the COTS demonstration flights, so that when we got docked, there was actually some cargo that was able to be transferred as part of a demonstration of the COTS capability to station. So we got some operational advantage out of these demonstration flights. There's a lot of detail, a lot of discussion occurred about how we set up these gates, the strategy for approach, etc. And that was based on what we had done previously with the automated transfer vehicle from the European Space Agency, and it was backed up or based on what we did for the Japanese transfer vehicle, the HTV, which delivers cargo. So the station program had experience of working with another provider other than shuttle, the Europeans and the Japanese. So then it wasn't totally foreign to them when they now had to interact with another commercial partner. And so then they were, understanding of different specifications, meets requirements instead of always, you don't have to meet the requirements exactly the same way. We call it, equivalency. Are you meeting the requirement in an equivalent way? Maybe not in exactly the same way, but is it acceptable? And so the station program had a lot of experience of working with new providers, new requirements, new equipment, bringing a new system into station, as they did with the previous European and Japanese cargo vehicles. So when the cargo and COTS activity came along, they were already accustomed to working with another partner with a different way of doing business, a different engineering design philosophy. So they were accepting of that overall process. But again, the NASA teams had to work really seamlessly together between the C3PO folks and the ISS folks back and forth. Just tremendous amount of data exchange to make sure we're providing the same expectations to the contractor and the workforce of what we're trying to do and move forward and accomplish. But again, I think that shows another degree of integration that is absolutely critical to making this happen, that the organization that's going to receive the new capability has to be receptive and trust the organization that's building the new capabilities such that they can work together. Talk a little bit about the safety review process that station used to make sure that these vehicles were really safe and were ready to go ahead and approach station. And so again, I think that thing that's important there is, it's based on hazard and hazard controls. So the program really identifies and the contractor identifies what hazards they believe are associated with coming in to dock or to be berthed or picked up by the SSRMS from a station standpoint. And then they have to show how they control those hazards or they control those risks. So this is a fairly methodical process that the teams go through to establish how we they come into station. So there's lots of discussion that occurs about rendezvous prox op sensors and redundancy in those devices. What data do you need out of this device? And all that comes out of this kind of hazard identification, hazard risk mitigation process. So this SRP process, provides a very sound basis and provides a very good way for the contractors to work with NASA and for NASA to describe our requirements in a way that's real, and it's not just a static requirement. We're actually describing an operational scenario or an operational risk. The contractor can see that, tell us how their hardware is going to address that operational risk or that operational hazard, and our teams can then judge, is it acceptable, is it robust enough, and it makes for a very good dialogue back and forth. And we do that typically through a phase 1 safety review where you handle it at the conceptual level, phase 2, which is a little more refined, and then in phase 3 is the actual details of looking over the procedures, looking over the hardware to make sure that all those concepts you laid out in phase 1 and phase 2 are really implemented in the actual design in phase 3. So it's a very thoughtful, methodical process to look at hazard identification and control.